Now, I would like to talk about homologous series. So basically, there are a lot of carbon compounds, and some carbon compounds can be classified into their own respective groups, and we call that homologous series. So the main homologous series that we have to learn will be alkane. I'm gonna write them gut by gut because I want to try and write the characteristics together. Alkyne, alcohol, carboxylic acid, and ester. But ester is basically these two combined together. I'll mention that in another video. So the things that you need to have to determine a homologous series is general formula, and functional group. So how do you determine the general formula? I mean, how do you know which general formula belongs to alkene, alkane, alkyne, etc.? So the general formula for alkane is CnH2n. For example, if they give me a compound that is C4H not CnH2n, CnH2n plus 2. So if they give me C4H10, I know that this is an alkane because it follows this general formula. But every homologous series have their own general formula. For alkene, it's CnH2n. Alkyne is CnH2n minus 2. Alcohol is CnH2n plus 1 OH. And carboxylic acid is CnH2n plus 1 COOH. So that's the general formula. But how about the functional group? The functional group of an alkane is carbon-carbon single bond. Alkene is carbon-carbon double bond. Alkyne is carbon-carbon triple bond. Alcohol is hydroxyl group. And carboxylic acid is carboxyl group. Carboxyl. I think you should know how to spell hydroxyl, but I'll just write it here anyway. Now, what this means is alkanes are saturated hydrocarbons, while alkenes and alkynes are unsaturated hydrocarbons. And alcohol and carboxylic acid are non-hydrocarbons. So yeah, that's basically something that you have to keep in mind, because maybe it'll come out in objective, but subjective, they probably won't ask something that easy. So yeah, they all have their own chemical properties and their own physical properties, but we'll get to that in another video. Right now, I just want to get into the naming or nomenclature and also the structural formulas. So I think I should get to the structural formula first. So if I want to draw an alkane, okay. Let me just erase this first. Okay, let's say I want to draw an alkane. So how do I draw an alkane? First of all, I have to determine what number of carbon molecules do I want. So let's say I want n equals to 2. So I want n equals to 2. Then I write off. So C, and then what I do is I just draw carbon all around them. So the key to drawing a structural formula is you need to be aware of the number of bonds the carbon has, or in a more understanding term, how many lines is carbon connected to, how many lines is around carbon. So in this case, carbon has 4 lines. So that means I wrote this correctly. How about alkene? CnH2n. So that means C2H4. So I need to draw 2 carbon and 4 hydrogen. So C, and then double bond because that's its identical group, and then H. This is correct. Why? Because carbon has 4 lines around it. 1, 2, 3, and 4. If I were to draw something like this does not exist. So it's wrong. For the hydrogen to be here, this bond must be broken, but it's not broken yet. So that's why that doesn't exist. So this is an alkene, and then alkyne, CH triple bond, and then alcohol is similar to what was it again? Alkane, which basically is single bond, is saturated, and then H, 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 and then OH. Here's the main part, the OH here. I'll get to more later, but in advance, just know that if you want to draw a line, the line must be connected to the O, not the H. If you connect it to the H, it will be wrong. Even if you draw it in the middle like this, it will be wrong. You must draw it like this. It's connected to the O. Carboxylic acid is, let's say I want to, so C. Oh wait, now is the part where I want to get a bit more pattern a bit. So there is a difference between N equals to 2 and 2 carbon molecules. For everything here, these are normal because there's only Cn ma. But here we have Cn and C. So the total number of carbon molecules is your N plus 1. So if I want 2 carbon molecules, not 2 carbon molecules, atoms, sorry. If I want 2 carbon atoms in my carboxylic acid, then my N has to equal to 1. So to draw it, CH3, COOH. So to draw it is CH, H, C, double bond O, OH. And yeah, so that's basically how you draw easy carbon compounds. Now, time to get into the itty-bitty grid of it, like the more confusing parts. So number one is we have something called alkyl groups. So alkyl groups are basically what we know as branches. It's like if you have a tree and then it's like branches growing out of it, but then they're all made out of wood, right? They're all still wood. They're still lignin, so they're still similar, but then they're not the main body. So alkyl groups are the same thing, where you have a lot of carbon, but you have an outsider, which has its own chain. So like even though there's a lot of hydrogen here, there is an extra carbon that is not part of the carbon chain. So the thing that we have to know is we want to determine when is this outsider an alkyl and when is it part of the carbon chain. So my tip for you is don't think that only straight lines are carbon chains. Straight lines are carbons that are connected to each other in one sequence or in one line. Like if I connect the carbon like this, or if I connect the carbon like this, Z shape, L shape, then this is a carbon chain. So if they ask for, let's say these are all hydrogen, all single bond. So this is 1, 2, 3, 4, 5, 6, 7 heptene. Not pentene. It's not pentene, it's heptene because these two are also part of the carbon chain. However, if let's say that this time, instead of your carbon chain being at your carbon being at the very end, it's in the middle. Then this is your new group. This is your alkyl. So in SPM we learn mainly methyl and ethyl, but methyl is more common. We use methyl a lot when naming when we are asked to label structural formula. So that's that. Now here's the thing. There are also times where you need to determine what is the longest carbon chain. So let's say I have C, and then I draw C here, and then I draw C here, and then I draw C here. So what is the longest carbon chain? Is it 3? No, it's 4. That is the longest carbon chain. Or 4. They can be like that. So you need to be careful with determining what is your carbon chain, because the carbon chain is the one with the most number of carbons. So even though this is 3 and in a straight line, and these are in the middle, your carbon chain is still this, because that has more than this middle line. So yeah, just something to keep you to keep you thinking about. So that's why you don't have such things like this. I mean we do, but yeah, that's why we don't have things like that's why that's why people don't really ask if we have something like this, right? We don't say that this has an ethyl group. We say that this is the chain and these two are methyl groups. What people might think is that this is your chain and this is an ethyl group, which is what I thought last time. But remember, we want to find the longest carbon chain. So yeah, just something to keep your to keep it in your mind while thinking about it. Now to the very fun part, in my opinion. So we have something called isomers. The thing about isomers is they have the same general formula. In the same general formula. But they have different structural formula. So what is the structural formula? Basically what I did just now. What I did just now. These are all structural formula. So before I get more into isomers, I need you to know prefixes and suffixes. So prefix is your imbuhan awalan, and suffix is your imbuhan akhiran. So your prefix are based on the number of carbon atoms in your formula. For example, if I have one carbon atom, that is called meth. That I start my naming with meth. For example, methane. If it's 2, it is F. 3, it is prop, and then but, pent, hex, hep, oct, non, and dec. So yeah, these ones are quite rare, but they ask mostly about propene and prop and but. So that's your prefix. Your suffix is basically the imbuhan akira that you end at the end. So it depends on your homologous series. So it's either ane for alkane, in for alkene, ein for alkyne, anol for alcohol, anoic acid for carboxylic acid, and ester is that was a bit more confusing lah. So yeah, again, the name of your carbon compound depends on these two. For example, if I have this, I'm easy to draw hydrogen. So if you see just this, later I'm drawing hydrogen. I'm gonna draw it for now, but later when I get to the longer parts, I'm not gonna draw it anymore. So this is 3 carbon compounds. 3 carbon compounds, 3 carbon atoms, and it has single bond only. So this is propane. Or if I change this to OH, then this is propanol. And then yeah. And then if I change this to, let me see if I can find something interesting. COOH. Then this is propanoic acid. So yeah, that's the easy part. Now we get to the more pattern part. Now, the name of your, the nomenclature of your isomer, back to isomers. Isomers have the same general formula, but different structural formula, right? So for example, let's say I want to draw something that is C4H10. And let's say I want to draw something that is C4H10. So there are two main isomers. Number one is this, and number 2 is this. So this is what we call butane, and this is 2-methyl propane. Now, you might be wondering, why is it 2 here? Now that's the part where we need to be a bit more careful on. When you have an alkyl group in your compound, you need, or actually anything that is not hydrogen in general, for example, OH or Cl or Br, anything that is not hydrogen, you need to state their position in the carbon chain, in the carbon compound. So yeah, you need to mention which carbon atom are they on. So this 2-methylpropane shows that the methyl group, the methyl that we have, methyl is CH3. The methyl group that we have is on the second carbon atom. But Here's the thing. If I were to draw something like this, and then put CH3 here, and then there's all hydrogen. So I'm gonna draw all hydrogen. I call this, what do you call this? Do you call it 3-methyl or 2-methyl butane? I will call it 2-methyl butane because we want to find the smaller number to choose our you're gonna choose the smaller number for our methyl group. So the small number is 2. Remember, we can count from either the left or right. So 1, 2, 3, 4, or 1, 2, 3, 4. We want to choose this one because 2 is smaller than 3. So the answer is 2-methyl butane. So that is for methyl group. But how about okay, let me see if there's any other examples that I can talk about. How about this? What if I put OH here? This is propan-1-ol. Weird, right? When you have for alcohol, alkene, and alkyne, this number depends on where your functional group is. For example, if I have C double bond C, 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 then this will be called but-1-ene because it's located on the first carbon atom. We wanna look at the smaller number, remember? We wanna look at the smaller number, so it's but-1-ene. And then this one is propan-1-ol because it's located at the first one. Or if it's C triple bond C, then it's but-1-ene. Now, this only applies for this one, for alkene and alkyne. This only starts after butene and butane. For this one, it starts at propanol. Why? Because if we have ethanol or propene, here can be 1, here can be 1, right? So either side is also 1, so you don't have to write it down. But if there is a chance for it to be either 1 or 2, we write it as 1. So yeah, that's that. Let me see if I mentioned. You also have to mention the number of alkyl groups. For example, if I have an alkane, again, I'm going to use alkane more. And then I have, here is CH3 and here is CH3. So I call this 2,2,2,2-dimethyl pentane. Because its carbon is located in the second carbon chain. Except third, no, sorry, my bad. It's 3,3-dimethyl pentane because it's located on the third carbon atom. How about if I have, instead of here, I have 1 here and 1 here. Do I name it 2,2? No, it will become 2,4. How about if I have this? Let's say I have my group here, and then I put my metal here. Do I name it 2-methyl pen-4-ene, pen-3-ene, or 3 or 4-methyl pen-2-ene? We want to always look at the functional group first. So this is second atom. So 1, 2, 3, 4. So it will become 4-methyl pen-2-ene. You can either write it as 2-pentene or pen-2-ene, but I'm more used to pen-2-ene because it's more, I guess, used. It looks ugly, I know, but it's what I'm used to now. So that's why. Okay, let me see if I forgot to mention anything. Okay, it says that there are two types of isomerism, a structural isomerism. Number one is chain isomerism, which is basically the example I mentioned earlier, butane and 2-methyl what's it again? Yeah, it was butane and 2-methyl propene and 2-methyl propane. I'm sorry. These two are chain isomers. But position isomerism is the position of your functional group. So 2-pentene and pen-2-ene and pen-3-ene are position isomers. Okay, so isomers have the same chemical properties because each isomer has the same functional group. Wait, let me see. Oh yeah. They have the same chemical properties, but isomers have different melting point and different boiling point. There is a pretty good reason why, but it's more explained in UEC. So yeah, I'll explain it more when I talk about like properties. Okay, let me see if I mentioned anything, if I missed out on anything. The textbook combines them together, so it'll become 4-methyl propan 2-ene. So yeah, just keep that in mind. Let me see if I missed out on anything. I don't think I have. There are other types of common compounds like but-1,3-diene or but-1,2-diol, but those are more towards the harder parts. And for you to understand, just read the textbook. If you understand this, you should be able to understand those more complicated ones. So if I'm not wrong, I think that's all for naming.